Hi everyone, today we're going to be looking at the Click PLC to Stride Field I/O Modbus TCP. Now, detailed information contained in the video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start your video 1. There will be links to the rest of the videos in the series as well. So what we're going to do is look at the Click, and it can use remote inputs and outputs from Stride. Now, the Stride Field I/O modules are simple and compact, and they provide economical means of connecting inputs and outputs to an Ethernet Modbus TCP communication network. Every module operates as a standalone Modbus TCP server and can be configured via the built-in web server. And last time what we did was we actually configured these modules using the web server, and we showed the features and benefits of each one. So I guess the first thing we'll do is take a look at our actual hardware. So if we look at this, we have our Click PLC right here. Then we have our power supply, our readable power supply, powering up our two modules. And the two modules are our Stride SIO MB12 CDR, which is our input-output module, 8 in, and then we have 4 relay outputs. Then we have our Stride SIO MB04 ADS. That is our analog input. It provides 4 channels. Each channel has a voltage and a current input. So, and what I have configured or wired is my analog input, and I have a potentiometer here. As I turn the pot, it will actually send a signal into my control unit here. And I do have wiring diagrams as well. And then we have our this card here, our I/O card. And I've taken the first output, which is the relay output, and put it back into the input. So as I trigger my relay output, my input then turns on as well. So that gives me some signals to look at in my program. So if I actually look at the wiring diagram, this is what I have here. And this 4 relay output, 8 digital input card, what you'll see is there's my 24 volt. And what I do is I take my common and it goes to my 0 volts for my input side. And then my output side comes from the first relay out, which is the normally open part of that. And then my common of that relay goes back to my plus 24. So that is a sourcing input that we're using for all these inputs, and they are sourcing. So you can see that we actually provide a positive to that input for operation. And then on my potentiometer, you can see here I have a 9-volt battery, and that 9-volt battery then supplies the potentiometer here. And as I turn it, it changes the voltage and it applies it to pin 4 and 2 of my module. So that is the wiring that I have for the actual unit. So if we look at the setup, and last time we put in the address of 192.168.1.131, which is the address of this first module here, and we'll put in our password. First of all, the username, ACC, and ACCA for the password. We log in, and there's our network address, our system configuration. You can see here that we're Watchdog enabled, and we're setting that for 3 seconds. So if I do not receive a Modbus communication within 3 seconds, it will activate our Watchdog event to happen. And then we also have a power event that we can actually look at that. Software updates as before, username and password, our inputs. You can see our state of our inputs and or outputs, and we can just read that, and you see everything's off. Then our outputs and the state of our outputs, we'll refresh that. And you can see that one's on right now. So if we look at the digital input, we can see that one's on as well. So which matches what we see. And then we can read and determine whether it's on or off. Okay, so that is our setup, and that's how we've set up the first Stride remote I/O module. Now let's take a look at the second one. Again, ACC for the username, password ACCA. And again, this is my address, system configuration. Again, what we have is our Watchdog enabled, and again for 3 seconds. So after 3 seconds of no communication, it fires this event so that I can pick that up in the Click program in order to determine whether or not I have good communications. Again, software update, username and password, and then my analog. And you can see here, I can read that. And right now I'm at about 9 volts. So if I turn down my potentiometer, and I just read that again, you see I'm at about 8 volts now, 7.958. So that seems to be working. And with both these modules, what I'll do is just log out. So that is our setup for the modules. So this is the PLC program itself. And what we're doing is we have 3 different parts. We have our main program, and then we have our subroutines. We have 2, one to handle the MB12 CDR, which is our input-output module, combination module, and another one to handle our analog input module. So this is our sample program on our main right now that we're looking at. And if we look through it, you can see that we've taken our system flags, our Watchdog event and our power-up event for this flag. We've labeled them into internal registers into the Click PLC program. Then we have our digital relay, and our status can be found at C141 to C144, and our control will be on C181 to 184. Then we have our digital input addresses. So we have our actual input, 0 to 7, which is our 8 inputs, correspond to C151 to 158. Then we have a rising edge. Because of the communication and the delay for communication, we look at, we can still bring in things quite quickly by using this rising edge trigger, so we don't fail to see something. And the rising edge trigger will be C161 to 168, and our falling edge trigger, so when the signal turns from on to off on our input, that'll trigger edge trigger 171 to 178 in our Click PLC. Then our input frequency, again, the card has some features in it that actually comes up and actually tells you what we want to look at. And our input frequency, DS105 to DS108, will handle the first 4 frequency inputs. Then what we have is we have our first call, and the call goes into the remote module or into the subroutine, which then will activate the information and bring those back in. Then what we have is in our main program is the event. There's a Watchdog timer and the power-up event. So the Watchdog timer, again, after 3 seconds, what I'll do is actually unplug this unit. And when I unplug it, after 3 seconds, what you will see is now my flashing indicator saying that, look, I have a Watchdog interrupt happen here. And then if I reestablish the communication, you will see, first of all, it then clears that error, but then I have a count here saying, yes, I have a Watchdog event happen. So now it's at 22. The other thing I have is a power-up event that I've programmed too. So if I were to take the power off the unit, so there I powered it down, and now when I power it back up again, you can see it'll go through, it'll establish communication, and we're back up and running once again. But now I've triggered that, and now I have 11 in there indicating that I did have some sort of fault. So then the next part of my program is actually the analog, and again I set up my Watchdog timer and my power-up timer at C210 and C211. I have my analog input types, okay, which are at DH27 to DH30, and that gives you each of the channels. Then we have our analog input addresses, So DS201, DS204, and all the way down to DS208. All right, so DS201 to DS208, that gives me my 8 analog input. And then I call my analog here. So I call the routine, which is this one right here, and it will then grab all that information and populate these flags for me. Next part of my program is I do have my Watchdog for this card, and I have my power up event for this card. So again, that will allow me to see what's actually happening if by losing power or if there's communication lost. Next, we have the actual program that we're running right now. So we have two timers, timer 1 and timer 2, and it's being set by your analog input. And on the analog input, what you'll find is that if I were to change this value, and we will bring it down a little bit, you can see that the numbers are now dropping. And what it does, it sets it up that it turns the output on and off depending on that time frame of my analog signal. So that's all this program is doing right now, is firing off that relay output. And once that relay output is fired, it activates the input, and then we can tell what's happening. Next, what we want to do is actually try to determine the actual overall throughput of the system using these remote I/O modules on our Click PLC. In order to do that, what we do is once we have our relay output fired or turned on, we set a bit. In this case here, it's C99. Then when we have C99 on, what we want to do is we just want to add every scan to DS10. So this counts the number of scans that we have. Then when we have, we read the relay input, what we want to do is say, okay, now copy whatever's in DS10, the number of scans, to DS11, and then we're going to zero DS10. So basically every time our input turns on and we have confirmation that it is on, we calculate the number of scans it takes to do that and put it into DS10 or DS11. So currently right now, I'm looking anywhere from about 38 to right now 55 scans of the PLC before those inputs I determine whether it's on or off. So if we look under PLC or monitor, one of these will actually have a scan time, which is under setup. And here it tells me my current scan time. And currently right now it's at 1 second. So current is about 1 second. So if we look at throughput, then right now if we have a 56 like we show right now, then it's 56 milliseconds is our throughput of our system using these remote I/O. So just a quick little way of doing that. And then that's the end of our program. So going back, the first thing we do is we call up our subroutine here, which is the MB12 CDR. So we do that, and during the first scan, what we want to do is we want to go back into our Modbus and do our read, and we default port 502, and then we do slave 1, Modbus function 3, and we want to read slave address 40,011. And then we are reading 3 words, and there's no word swap. So that is the first read. Now to get that information, if we go back to our Modbus addresses that we had before, here we go. You can see here that we're reading this one right here, which is our system flag. So we have our system flags, and we're reading our power up and safe, and we're reading our Watchdog timer. So those 3 different registers within that unit. So going back here, you can see that's what we're doing, reading those 3 registers. And then we put them into DS1, or sorry, DH1. Next, what we do is after a successful read, we break those flags out into individual bits using a copy command. And you can see here, and then we break out the power up and safe mode. Now, power up and safe mode just allows us to set bits in there according to what we want to happen when things are powered off or we lose communication. In our case here, our power up and safe mode, we're turning all those bits off, and when we turn those bits off, the outputs will not fire. So that is our safe mode. Then we have our Watchdog timer, and our Watchdog timer right now is set for 3 seconds. So that's why we have a 3 there. Next, what we want to do is we want to take our Watchdog event, and if it's on, then we take our write information and put it in. Then we take our Watchdog, if it's off, then we keep it off and put 0 into our Watchdog event. And what this will do is we're going to write this values back in for our safe mode and our event that we're going to look at. So what we do is we set those up, then we use our setup bits, our safe bits, we move those all at 0 into DH5, and then our time will leave that same as 3 seconds. And then what we want to do is write that information into right here. We're going to write that information into the PLC to get the status. Right? So that's the receive. There's our write right here. So our write is actually going to write our 3 values starting at DH4, and that will write our events back in. So then after we write our events back in, then we want to read the status of the I/O. So in this case here, we're going to start at 4,000 or maybe 400,031, and we're going to read 16 registers. Again, looking back at our Modbus addressing, there is our 31 right there, digital outputs, and we're going to read the from here all the way down to our counters, so that down to 45. So that gives our 16 registers that we're reading in. So once we read those in, then what we want to do is we again break those digital inputs and outputs out. There's my digital outputs. I break them out into my C bits. Then my inputs, I break those out. And my rising bits, I break those out. And my falling bits, I break those out into individual bits. Then what we do is we then we'll copy our information into DD1. This is for our count value. So our counters then go, because they're 32 and we're reading 16, we take 216 and we put it into 132. So DD1 represents 32-bit information. So each time that my output fires, my counter then increments. So we can see here that I have a 32-bit counter here, which is 0, 1, 2, and 3. So my first 4 inputs operate counter, and my first 4 operate my frequency. So after I've done that, then I take a look at my rising edges and my falling edges, and if they are true, if my rising edge or falling edges are true, then what I want to do is reset those leading or rising and falling edges so I can catch the next pulse. And I do that, I zero them out, and then I write that back into address 33. Again, looking back at 33, you see that these are my rising edge and my falling edge addresses that I'm actually resetting now. So once I reset those, then I write my 4 relays. So I take C181 to 184, that gives me my 4 relay outputs, and I put it into DH7, and then I write that information into the unit. Again, at mod or IP address 192.168.1.131. And then you'll notice that I have for each one of these a write sending, a write success, and a write error. I pick up on the write success and error to continue with my next operation. Then once I've done that writing of my outputs, then I have a write success, and then I have my completed MB12 CDR Stride remote I/O card. So let's now look at our analog in, and again it's going to be very similar to what we just done. We've taken that output or the update completed for our other module and used it to trigger the next read for my analog card. And again, the only difference basically is we have changed our IP address to 132 now. So once we read that information, again we start at slave address 40,011. So if again we look at our Modbus addresses, this is the one for our analog input, and again it comes up with our system flags and our Watchdog timer. So we're reading those values in. So when we read those values in, then what we do is after a successful read, we take those bits and we break them out into our flags. We take our Watchdog event and we'll move this back in. And if it's not set, we put 0 back in. So when we write those Watchdog flags back in to reset, then they will put in. So our Watchdog and our system flags then get written into our unit by this. Then we have a read the remote I/O. So again, what we do is we're going to read 4 channels, starting at 31, and 31 being the input type. So we're going to read 4 of these, which is our input types. And when we read those, we're going to put those in DH27. So as we discussed before, we have to really break out where we want information to be before we put it in. Then once that's complete, then we want to read all of our channels in. So our 8 channels that we have for our analog values. And that starts at 41. And once again, I look back here at 41. Here is my analog in, and there's my 8 values. So I'm reading those in to get the status of the analog itself. And then we go to our update, and that's it. There's our return. So that is the entire program that we've had programmed. And what we have is to monitor it, we have this main. And under the main, you can see that we have our current counts for our Watchdog and our power-up events for each of the modules. We have our throughput system here, which gives us our 56 scans. We have our frequency of our input, which is set right now for 1, and we have our count value for DD1. So if I were to decrease the time so that my pulses become a little quicker, we can see that the frequency will change as well as my count will start changing. There we go. We'll just lower that down quite a bit. You can see that's bringing it down. So you can see a frequency here, you can see my count. Just like that. Then what we can do is we can actually then look at, on our data view, we'll call up our MB12 12 CDR module. And we can see the information here, our Watchdog timer. We can see our power off events and logic events. So, and then our setup for our card. And finally, if we call up our analog, there we go. That was our analog, our power up events. And then this is our digital I/O, remote I/O card. And you can see how all of our relays, there's my run reading and writing going on and off as per our unit clicking on and off right on this one here. So if you enjoyed this video, please hit the like button below. If you have any questions about the video, please leave a comment below and I'll do my best to answer it. Remember to download the actual program so that you can review this on your own and all the details within the program itself. If you want more information about us or you want free ebooks on numbering systems or robust data logging, please click on the link in the description below to get it. A new video is put out every Monday, so make sure you hit the subscribe button so you get more videos like this in the future. Remember to click that bell beside your subscription to actually receive those notifications. Thanks so much for watching. I'll see you next time. Stay safe.